Hello viewers at home, this is Helizchem, your favorite channel. Today we want to look at factors affecting preferential discharge of ions during electrolysis. In my last video, I talked on position of ions in the electrochemical series, and I promised you guys that I'll be talking on the other factors, which are concentration of ions in the electrolyte and nature of electrode. So listen as I talk on concentration of ions as it affects discharge of ions during electrolysis. Now, concentration of ions. That is what we want to talk on this morning. Increase in concentration of a given ion tends to promote its discharge from solution. That is, when you increase the concentration of ions, then the ions are having tendency to be greatly discharged from solution during electrolysis. However, I want you to know that the influence of concentration is effective only when the two competing ions are closely positioned in the electrochemical series. Don't forget that in my last video, I listed the position of ions in the electrochemical series for you, for both anions and cation. So what we are saying is that for concentration of ions to be effective, then the two competing ions must be closely positioned in the electrochemical series. But the influence of concentration becomes minimal, or let me say less important, if the competing ions are widely separated in their position in the electrochemical series. What am I saying? I'm saying that the effect of concentration is less important if the relative position of these two ions that we are talking about are widely separated, if they are far apart from each other in the electrochemical series. For you to understand better, let us use this particular example. For example, electrolysis of concentrated sodium chloride solution, otherwise known as brine. Don't forget, I use concentrated. That is what we are going to use for this example. In concentrated sodium hydroxide solution, we have the following ions. From sodium chloride, aqueous, we have sodium ions, aqueous, plus Cl minus aqueous. Don't forget, we said that this is of high concentration. And normally we have water in liquid form. This also will ionize to give aqueous plus OH minus aqueous. Don't forget, low concentration. Now at the cathode, we have sodium ions and hydrogen ions migrated to the cathode. When they get to the cathode, hydrogen ions, though lower in the series than sodium ions, are preferentially discharged. We expect that since sodium ion is of high concentration, that it will be discharged, but instead of that, hydrogen ions are discharged. And why? You will see that in the electrochemical series, the position of sodium ions to that of hydrogen ions, they are widely separated. You have a greater distance between these two ions, and this one neglects the effect of concentration of sodium ions. Are you getting me? So I am saying that hydrogen ion will be discharged to what? To sodium ion, because the far distance between the position of the sodium ion and hydrogen ion in the electrochemical series, and this makes the effect of concentration to be what? To be less important. So here now, hydrogen ions will be discharged to give hydrogen gas. Hydrogen will combine again to give H2 gas. In essence, we are saying that we have 2H plus 2E to give H2 gas. But at the anode, let us see what happened at the anode. At the anode now, these two ions will migrate to the anode. We have chloride ion and what? Hydroxide ion. This is where the effect of concentration is important, because at the anode, chloride ion will be discharged, and we have something like this. Cl plus Cl will give Cl2. And in the same manner, you can just write it directly like this. 2Cl minus 2E to give Cl2 gas. But in chemistry, we don't write a negative equation. So we have something like this. We have Cl2 plus 2E. That is that. Now let me explain. Chloride ion will be discharged because of the high concentration. If you look at the position of hydroxide and chloride ion, you discover that they are closely positioned to each other. They are closely positioned, and that is why the effect of concentration is important in this case, because the position of hydroxide ion and chloride ion are close to each other in the electrochemical series. So in essence, what we are saying is that as much as effect of concentration is very, very important for the discharge of ions during electrolysis, but there's this condition that is attached to it. This effect of concentration is important if and only if when the two competing ions are closely positioned in the electrochemical series. I want you to go back to the part 1 of this video, where I listed the electrochemical series for both cations and anions for better understanding. Because if you look at the position of chloride ion and hydroxide ion, they are what? Not far from each other, and that is why the effect of concentration is effective in this discharge. But in that of sodium ion and hydroxide ion, the position of sodium ion and hydroxide ion, they are far apart in the electrochemical series, and that is why you see that hydrogen ions are discharged in this case, making the effect of concentration to be less important. I hope you got values from this lesson of today. If yes, stay tuned for more chemistry topics. Don't forget to share, like, and subscribe, because Helizchem got you covered. Bye.